Welcome back to another deep dive from Peaceful Rooster Experience. Today, we're going to unpack some really cool stuff about how AI is changing the world of big data.
Okay.
Specifically, we'll be looking at how AI is being used to optimize Apache Spark,
Right.
taking it from a powerful engine to a supercharged rocket.
Mm.
You know how frustrating it is to wait for a slow query to finish?
Yeah.
Well, imagine if we could make that data crunching lightning fast.
Wow.
That's what optimizing Spark is all about, and AI is stepping in to make it happen in some really surprising ways.
Yeah, it's fascinating because Spark is already designed to handle massive data sets.
Right.
But like any complex system,
Mm-hmm.
it needs fine-tuning to operate at peak efficiency.
So true.
Think of it like a high-performance race car.
Oh, yeah.
It has all the power and potential, but it needs an expert mechanic to adjust the settings and get the most out of it. That's where these AI-powered optimization solutions come into play.
I see.
They act like that expert mechanic, making subtle adjustments and tweaks to get Spark running at its absolute best.
I like that analogy.
Yeah.
And just like a race car has different components that affect its performance,
Mm-hmm.
Spark has its own set of core principles we need to optimize.
Right.
So where do we even begin?
One of the biggest bottlenecks in Spark is data shuffling.
Okay.
It's like a chaotic traffic jam where data is constantly moving across the network, slowing everything down. Minimizing this shuffling is key to improving performance.
Makes sense.
Traditionally, we've used techniques like choosing the right partitioning strategy
Right.
or using broadcast joins to reduce the amount of data that needs to be shuffled.
Yeah.
But what if we could have an AI that could analyze our data and workload
Right.
to dynamically determine the most efficient shuffling strategy?
Interesting.
That's what some cutting-edge research is exploring.
Wow.
Using algorithms like reinforcement learning to teach Spark how to optimize its own data shuffling in real time.
That's mind-blowing. So it's like Spark is learning from its own experiences and becoming a better driver over time.
Exactly.
Yep.
And it's not just about shuffling. Another critical area is data serialization.
Okay.
Think of this like packing a suitcase for a trip.
Right.
You want to pack efficiently
Sure.
to minimize wasted space and make sure everything arrives in good condition.
Right.
Similarly, in Spark, we need to serialize data efficiently to reduce the overhead of transferring and storing it.
So true.
Traditionally, we've relied on choosing the right serialization format like Creo or Avro,
Yeah, I've heard of those.
but AI is starting to make a difference here too.
Really? How so?
Imagine an AI that can analyze the structure and characteristics of your data
Okay.
and dynamically choose the optimal serialization format for each dataset.
Wow.
This could lead to significant reductions in storage space and processing time.
So we've tackled the traffic jam and packed our bags efficiently.
Aha!
What's next on our Spark optimization checklist?
Data locality.
Data locality.
This principle focuses on keeping the data processing as close to the data itself as possible. It's like choosing a restaurant near your house instead of driving across town for dinner.
Okay.
The shorter the distance, the faster you get your food.
I could see that.
In Spark, this means making sure that the data and the code that processes it reside on the same machine or within the same network rack.
So like keeping things local.
Exactly.
Yeah.
We can leverage techniques like choosing the right partitioning strategy or manually pinning data to specific nodes.
Right.
But with AI, we can envision a system that intelligently distributes data and tasks across the cluster, predicting where data will be needed and preemptively moving it to the optimal location.
So AI is basically acting as a data traffic cop, making sure everything flows smoothly.
That's a great analogy. And finally, we have controlling partitioning,
Right.
which is all about dividing the data into smaller chunks that can be processed in parallel.
Right.
Think of it like organizing a library. If you have millions of books and only one librarian, it's going to take forever to find anything.
Yeah, that makes sense.
But if you divide the books into sections and have multiple librarians working simultaneously,
I
the search becomes much faster.
see your point.
In Spark, we can manually set the number of partitions or use techniques like repartitioning to adjust the data distribution.
Okay.
But AI is starting to play a role here too.
Oh, how so?
Dynamically adjusting the number of partitions based on data size cluster resources
Yeah.
and even the specific operations being performed.
Wow.
This can lead to significant performance improvements, particularly for complex queries that involve multiple stages of processing.
So AI is like that super organized librarian who always knows where everything is.
Exactly. And what's really exciting is that these are just a few examples of how AI is being used to optimize Spark.
I bet.
As AI research continues to advance, we can expect even more innovative and powerful optimization techniques to emerge,
That's really exciting.
making Spark even faster, smarter, and more efficient.
Okay, this AI-powered Spark engine is sounding pretty incredible.
It is
But let's get down to the nuts and bolts. Can we dive into some specific optimization techniques and see how AI is actually being applied?
absolutely. Let's start with a common problem that many Spark users face, dealing with null values in joins.
Null values. Okay.
Imagine you have two data sets that you want to join based on a common column,
Yeah.
but one of the data sets has missing values in that column.
I've run into that before.
Traditionally, we might filter out rows with null values,
Right.
but this can lead to data loss and inaccurate results.
Right, because even a row with a missing value might contain other valuable information we don't want to discard.
Exactly.
So how does AI help us solve this puzzle?
Well, instead of simply filtering out the rows with nulls, AI can be used to impute those missing values, filling in the gaps intelligently based on patterns in the existing data.
Okay.
This is where machine learning comes in.
Wow.
We can train models like regression or k-nearest neighbors
Right.
to predict the missing values based on the other columns in the dataset. It's like having a detective who can analyze clues and fill in the missing pieces of a puzzle.
So instead of discarding potentially valuable data, we're using AI to make educated guesses about what those missing values might be. That's pretty impressive. But what about duplicate records? You know those pesky repetitions that clutter up our data sets and waste valuable storage space?
Duplicate records are definitely a headache.
For sure.
Traditionally, we've relied on methods like drop duplicates to remove exact matches,
Yeah.
but this can be too simplistic.
Nice.
AI offers a more nuanced approach through anomaly detection.
Anomaly detection. Okay.
Instead of just looking for exact matches,
Yeah.
AI algorithms can analyze the data and identify records that deviate significantly from the expected pattern,
Oh, okay.
flagging them as potential duplicates.
So it's like having a super sleuth who can spot subtle differences and inconsistencies that might indicate a duplicate.
Exactly, and this is particularly useful when dealing with fuzzy matching,
Fuzzy match.
where records might not be exact duplicates but still represent the same entity. For example, imagine you have customer data with slight variations in names or addresses. Traditional deduplication methods might miss these, but an AI-powered anomaly detection system could identify them and help you clean up your data more effectively.
This AI copilot is sounding more and more impressive by the minute. It's like having a whole team of data experts working tirelessly behind the scenes.
It really is quite powerful.
But what about the overall quality of our data? Making sure it's accurate, consistent, and reliable.
Data quality is paramount.
Absolutely.
Garbage in, garbage out, as they say.
So true.
Traditionally, we've relied on manual checks and rules-based systems to validate data quality.
Yeah.
This can be time-consuming and prone to errors,
Right.
but imagine having an AI that could learn from your data and identify subtle anomalies that might indicate a quality issue.
Okay, that's interesting.
This is where data quality anomaly detection comes in.
I see.
AI algorithms can analyze your data,
Ah.
learn the expected patterns.
And then flag data points that deviate significantly from those patterns.
So it's like having a doctor who can run tests and identify potential health problems before they become serious issues.
Exactly. And this proactive approach can help you catch data quality issues early on,
Gotcha.
before they have a chance to impact your analysis or decision-making. For example, an AI system might detect a sudden spike in customer purchases that deviates from historical trends. This could indicate a data entry error, a fraudulent transaction, or even a genuine shift in customer behavior that you need to investigate further.
Okay, this AI-powered quality control system is really starting to blow my mind. But let's shift gears for a moment and talk about something that can be a major bottleneck in Spark jobs.
Yeah.
Inefficient read and write strategies. You know those times when it feels like our Spark jobs are running on dial-up internet?
Uh-huh. You've hit on a critical point. The way we read and write data can have a huge impact on performance.
Totally.
Traditionally, we've had to manually choose the optimal strategy based on our workload and data characteristics.
This often involves a lot of trial and error and guesswork.
Yeah.
But what if we could have an AI that could analyze our data and workload and dynamically choose the most efficient read and write strategy?
Yeah, that would be helpful.
That's what some researchers are exploring with reinforcement learning. This type of AI can learn from past performance and adapt its strategies to optimize I/O operations,
Oh, wow.
making data transfers faster and more efficient.
So it's like having a self-learning Spark engine that's constantly improving its reading and writing skills That's pretty amazing.
It is.
Mm-hmm.
And as AI research in this area progresses, we can expect even more sophisticated and adaptive I/O optimization techniques to emerge,
That's great to hear.
making Spark jobs run smoother and faster than ever before.
Okay, I'm really starting to see the potential of this AI copilot for Spark optimization.
It's pretty remarkable.
But what about those really complex queries that involve non-equi-joins?
Non-equi joins, okay.
These can be real performance killers,
Yeah.
right?
You're absolutely right. Non-equi joins, where we're joining data sets based on conditions other than equality,
Right.
can be very computationally expensive.
Yeah, I can imagine.
Traditionally, we've tried to avoid them whenever possible,
Of course.
but sometimes they're unavoidable.
Yeah, that's fair.
AI can help us tackle these challenging joins in a couple of ways.
So how does AI approach these tricky situations?
One way is by acting as a smart join predictor.
Smart join predictor.
By analyzing the data and the specific join conditions, an AI model can predict the efficiency of different join strategies.
I see.
It might suggest using a more efficient equijoin if possible,
Okay.
or it could recommend alternative approaches to optimize the non-equijoin. Think of it like a chess grandmaster analyzing the board and suggesting the best moves for a complex situation.
So AI is bringing that strategic thinking to Spark optimization, helping us navigate those challenging joins more effectively.
Exactly. And as AI research advances, we can expect these smart join predictors to become even more sophisticated, able to handle increasingly complex join scenarios and provide more optimized solutions.
This AI copilot is really starting to sound like an indispensable tool for anyone working with Spark.
I think so too.
But before we get too carried away, let's take a deeper look at some of these AI-powered Spark optimization techniques and see how they work in practice. All right, so we've laid the groundwork and understand some of the core principles at play here. Now, I'm really curious to see how these AI-powered optimizations actually work in practice.
Sure.
Let's dive into some more specific techniques, shall we?
Absolutely. We were just talking about those tricky non-equijoins.
Right.
Now let's imagine a scenario where you absolutely have to use one. Traditionally, you might try to rewrite the query,
Okay.
maybe using common table expressions,
CTEs.
CTEs,
Yeah.
to make it more efficient.
Right.
But that can be a tedious process,
Uh-huh.
almost like manually untangling a giant knot.
Yeah, I can definitely see how that would be time-consuming and prone to errors. So how does AI step in to simplify this?
Well, imagine having an AI that acts like a super efficient code reviewer,
Okay.
analyzing your query and suggesting the best way to structure it.
Gotcha.
That's where a query execution plan optimizer comes in.
Query Execution Plan Optimizer.
This AI-powered tool can analyze your query,
Yeah.
understand the underlying data structures,
Yeah.
and then recommend the most efficient execution plan,
Mhm.
often involving CTEs for better performance.
So AI is not only automating the process of rewriting queries, but also making sure that the rewritten code is actually optimized for performance.
Ah.
That's impressive. It's like having a coding buddy who always knows the most efficient shortcuts.
Precisely. And this is just one example of how AI can be used to optimize queries in Spark.
I see.
There's also a lot of research going into using AI to optimize subqueries, which are queries nested within other queries.
Right.
These can be particularly challenging for Spark to process efficiently,
Okay.
but AI can help by analyzing the query structure and recommending the best way to restructure or rewrite it.
It's fascinating how AI is bringing this level of intelligence and efficiency to Spark optimization. It feels like we're moving away from manual tinkering and towards a more automated and intelligent approach.
Absolutely. And this trend is only going to accelerate as AI research progresses. Now let's shift our focus to another important aspect of Spark optimization: partition sizes.
Okay. Partition sizes.
You see, Spark divides data into partitions to enable parallel processing.
Right.
But choosing the right partition size can be a delicate balancing act.
Right. It's like Goldilocks trying to find the perfect porridge.
Aha, exactly.
Too small and you're not taking full advantage of parallel processing. Too big and you might run into memory issues or excessive shuffling.
Yeah.
So how does AI help us find that just right partition size?
Traditionally, we've relied on manual tuning and rules of thumb to determine partition sizes,
Yeah.
but AI offers a more dynamic and data-driven approach.
Okay. I like the sound of that.
Imagine having an AI that can analyze your data characteristics,
Okay.
the available cluster resources, and even the specific operations you're performing,
Nah.
and then dynamically adjust the partition size to maximize performance. That's what we're seeing with techniques like dynamic partition size tuning.
So AI is basically acting as a data partition magician, constantly adjusting the size of the partitions to ensure optimal performance.
Exactly. And this dynamic approach can make a significant difference,
Right.
especially when dealing with fluctuating data volumes or complex queries that involve multiple stages of processing.
Okay, this AI Copilot is really starting to sound like a must-have for any Spark user.
It's becoming increasingly essential.
But let's talk about broadcast joins for a moment.
Podcast joins, all right.
These can be powerful tools for optimizing joins, but I've also heard they can be tricky to use effectively.
You're right to be cautious.
Okay.
Broadcast joins involve sending a smaller dataset to all the nodes in the cluster,
Right.
which can significantly speed up joins.
I see that.
But if the broadcasted dataset is too large, it can overwhelm the memory of the nodes and actually degrade performance.
So it's a bit of a high-risk, high-reward strategy.
Yeah.
You need to know when to use it and when to avoid it. How does AI help us make those decisions?
Well, imagine having an AI that can analyze the size of your datasets,
Okay.
the available cluster resources,
Mm-hmm.
and even the specific join conditions,
Yeah.
and then predict whether broadcasting is likely to be beneficial or detrimental.
Interesting.
That's what a predictive broadcast join optimizer does.
Predictive broadcast join optimizer.
It acts like a traffic controller,
Okay.
analyzing the data flow and deciding which lane to use for the most efficient transfer.
That's a great analogy. So AI is helping us make smarter decisions about when to broadcast and when to stick with more traditional join methods.
Exactly. And this kind of intelligent decision-making is becoming increasingly important as we deal with larger and more complex data sets.
Okay, this AI Copilot is really shaping up to be an indispensable tool for Spark optimization. But let's talk about another aspect that can impact performance. Caching.
Caching.
Storing frequently used data in memory for faster access.
Right?
But I've also heard that excessive caching can actually be counterproductive.
You're absolutely right. While caching can significantly improve performance,
Yeah.
caching too much data can lead to memory pressure, evictions, and even slower overall execution.
Oh, wow.
It's like trying to fit too many clothes into a suitcase.
I know that feeling.
You end up with a jumbled mess, and it's harder to find what you're looking for.
So we need to be strategic about what we cache and what we don't.
Yeah.
How does AI help us strike that balance?
Well, imagine having an AI that can analyze your data access patterns, understand which data sets are frequently used,
Right.
and then predict which data sets will benefit most from caching. That's what a cache efficiency predictor does.
Cache efficiency predictor.
It acts like a personal assistant,
Okay.
prioritizing the most important tasks and making sure that the most valuable data is readily available.
AI is really bringing a whole new level of intelligence and automation to Spark optimization. It's not just about following predefined rules anymore. It's about having an AI that can learn, adapt, and make intelligent decisions based on the specific characteristics of your data and workload.
You've hit the nail on the head, and this is just the tip of the iceberg. As AI research continues to advance, we can expect even more sophisticated and powerful optimization techniques to emerge.
I'm excited to see what the future holds,
Me too.
making Spark even faster, smarter, and more efficient.
Okay, but before we get too lost in all the possibilities, let's address a common issue that can bring Spark jobs to a screeching halt. Out-of-memory errors.
Outer memory.
Out-of-memory errors, yeah. It's like trying to fit too many people into a small room.
Okay.
Things start to get uncomfortable and eventually someone's going to get pushed out.
Mm.
And Spark-OM errors often occur when we have too many partitions leading to excessive memory consumption.
Right, so managing partitions effectively is crucial for avoiding those painful crashes.
Right.
Traditionally, we might manually adjust the number of partitions using repartition.
Right.
But that sounds like a lot of trial and error, especially when dealing with large and complex data sets.
It can be, but imagine having an AI that can analyze your data size,
Okay.
cluster resources,
Mm-hmm.
and the specific operations you're performing, and then dynamically determine the optimal number of partitions to avoid OM errors while maximizing parallelism. That's what we're seeing with techniques like dynamic partition count tuning.
So AI is acting like an event planner, making sure everyone has a seat and the room doesn't get overcrowded.
Precisely. And this dynamic approach can be a game changer for large-scale Spark jobs,
Instantly.
preventing those frustrating OM errors and ensuring smooth and efficient execution.
This is all incredibly fascinating. It feels like AI is transforming Spark optimization from a manual, reactive process to a more automated, proactive, and intelligent system.
Exactly. And we're just scratching the surface of what's possible. As AI continues to evolve, we can expect even more sophisticated optimization techniques to emerge.
I can't wait.
bringing us closer to a world where Spark can almost tune itself,
Wow.
adapting to changing data patterns and optimizing performance in real time.
This AI copilot is definitely revolutionizing the way we work with Spark.
Hmm.
It's not just about speed, it's about making smarter decisions, reducing errors, and ultimately empowering data scientists to extract more value from their data.
Well said. And it's about freeing up data professionals to focus on the more creative and strategic aspects of their work while AI takes care of the heavy lifting of optimization.
I'm really excited to see how this field continues to evolve and what new possibilities AI will unlock for Spark optimization. But before we get too carried away, let's take a moment to reflect on what we've learned today and discuss some key takeaways for our listeners. Wow, what a journey this has been. It feels like we've explored the inner workings of a high-performance engine and glimpsed the future of data processing. I don't know about you, but I'm feeling pretty energized by all the possibilities we've discussed today.
I agree. It's an exciting time to be working in this field. The advancements in AI are rapidly transforming the way we approach Spark optimization, and it feels like we're just getting started.
So as we wrap up our deep dive, let's distill the key takeaways for our listeners. What are those aha moments that they should walk away with?
First and foremost, AI is no longer just a buzzword in the world of Spark optimization. It's a real game changer, bringing intelligence and adaptability to a process that was once largely manual and time-consuming.
Right, it's like we've gone from using a basic wrench to having a sophisticated toolkit equipped with AI-powered tools that can diagnose, adjust, and optimize our Spark jobs with incredible precision.
Exactly. And the second takeaway is that AI-powered optimization addresses a wide range of challenges in Spark, from handling those pesky nulls and duplicates to making strategic decisions about partitioning caching and even choosing the right join strategies.
It's like having a team of Spark experts working behind the scenes, constantly analyzing our data and workload, and making those fine-grained adjustments that can make all the difference in performance.
And the third takeaway, which is perhaps the most exciting, is that this is just the beginning. As AI continues to evolve, we can expect even more sophisticated optimization techniques to emerge.
But we're really on the cusp of a new era in Spark optimization where self-tuning systems become the norm.
Right.
Imagine a Spark engine that can learn from its own experiences, adapt to changing conditions, and continuously optimize itself for peak performance. That's a pretty compelling vision of the future.
It is indeed. And this brings us to a final thought-provoking question for our listeners. As AI becomes more integrated into Spark, how will its role in optimizing data processing continue to expand? What new possibilities will open up for data scientists and developers?
That's a fantastic question to ponder, because ultimately this isn't just about making Spark faster. It's about unleashing the full potential of big data to drive insights, innovation, and progress in every field imaginable.
Well said. It's about empowering data professionals to focus on extracting meaningful insights from data, while AI takes care of the complex and ever-evolving task of optimization.
So to our listeners, I encourage you to continue exploring this fascinating world of AI-powered Spark optimization. The future is bright and the possibilities are endless. Thanks for joining us on this deep dive, and until next time, keep exploring.